Yes, you can start, Samiksha.
Yes, ma'am. Ma'am, am I audible? Hello.
Yes, you are audible.
Okay, ma'am. A very good afternoon to one and all. I'm Sameeksha Sharma from third year Computer Science Department, and today we are going to learn the development process of the embedded system. So, starting with the very first process. Now, what
Just a
process?
second, Samiksha. So I want to introduce everyone. Every one of you knows Samiksha definitely. She is a great student of our department. And under the section of peer teaching, we are conducting this particular session. I'm very much happy that Samiksha has given her consent for this peer teaching, and she will be teaching you all about the concept of embedded system. So definitely study from her and take inspiration from her that she has taken this opportunity of peer teaching. Take that inspiration as well from her. So over to you, Samiksha.
Thank you, ma'am. So, starting with the very first definition, that is process. So now what process exactly is? So process is nothing but a series of actions, or we can say that or steps which are taken in order to achieve a particular end. Okay. So diagram is flashing on your screen, is we can say that a block diagram of how we can reach to the finished product, or say is the roadmap of how we get our finished product. Okay. Now we all know if we want a complete project or a finished project, so the raw material is the staple need to get our project. Okay, so we can say that when a raw material is converted into a finished project by means of any technique, then it is called as a process. Okay, so now in the terms of embedded system, ma'am, next slide please. So, in the terms of embedded system, the raw material is the problem definition, process is the hardware software development, and the finished product is our system. Okay, now what is problem definition? So, if we want to design a particular project, so first we need to design a problem definition. The problem definition plays an important role in our project. Okay, so our problem definition should be so precise that we should know that what we are exactly going to build and what are the shortcomings or flaws in the previous project, or we can say that in the already developed project which we want to overcome in our problem definition. Okay, so we can say that problem definition is the raw material of any developed system, or the system which we are going to develop. Okay, now what is process? So what type of process is done on the problem definition? Yes, we can say that we can do hardware development as well as software development. As we all know that embedded system is the collection of hardware devices as well as software devices, and by means of these devices we can get our result. Okay, so that's why process is nothing but the hardware or software development in embedded system. Okay, so on the problem definition, hardware and software development is performed, and yes, we get our finished product. Or we can say that problem definition is a raw material which is processed by means of hardware or software development, and we can get our finished product. Okay, so ma'am, next slide please. So for the development of embedded system, waterfall model is used. Now you all know what is waterfall model. You have studied this model in the software engineering also. Okay. So basically there are 6 phases in waterfall model. The first one is requirement engineering. Now what happens in a requirement engineering? Requirement engineering is the essential because in requirement engineering phase we get all the necessary requirements to build the project, or I can say that we capture all the possible requirements which are necessary to build the project. Okay, now what is suppose if we want to build a client based project, then we have to we have to gather all the possible requirements from the client, and on the basis of that we can start to build our project. Okay, now the next phase is of hardware and software partitioning. Okay, now what happens in hardware and software partitioning? So, firstly, we have gathered all our necessary requirements. Now we are going to partition it. Now, what is mean by partitioning? So, we are going to divide or partition the design into two parts. That is, of course, hardware design as well as software design, and this is also called as co-design. Now, what is co-design? So, co-design is simply a combination of hardware as well as software design. Okay, now we have combined. Now we have hardware and software design, or we can say that our combination of hardware and software design. Now the next phase is of implementation phase. Okay, now what happens in implementation phase? Now there are we can say that there are so many engineers who are working on hardware team, or who is working in the software team. Okay, but the work is parallelly done. Okay, so after implementing, the next phase is of integration and testing. Now we have gathered our requirements, we have done the partitioning, we have implemented it, and now we are saying that we are integrating it. Now, what that means? It simply means as so. Firstly, what is integration? Okay, so integration is the process of combining. As we have seen that in the second phase, we have partitioned the design into two parts, that is hardware and software. Now we are going to integrate, or we can say that we are going to combine those hardware and software design into a singular unit. And after integrating those units, we can test them. Now, what happens if we test them? So, after testing, or if we test them, we come to know that, or we verify that whether our system is working or not, whether our system is perfectly okay or not, or there are some flaws are there, or we can say that after testing, our system is error free, bug free, and we can say that our system is efficient to use. Now, the last phase comes, that is operation and maintenance. Now, this is the most important phase. Now, why this is phase is most important? Because up till now we have gathered requirements, we have partitioned them, we implemented the unit, or we have integrated it, and we perform the test on it. Now we all know that we have tested our system. Okay, but we have to give some policies, some rules by means of which the system can be maintained for many years, and it should be reliable and efficient. Okay, now I hope that you are very clear with the waterfall model. So let's move towards only the phases, but we are going to learn the phases in detail now. Okay, ma'am, next slide, please. Thank you, ma'am. So, again, the first phase, that is of requirement engineering. Now, embedded system development is divided into two parts, that is product development and turnkey project execution. Now, what is product development? Okay, in short, we can say that product development is redefining, enhancing, or we can say that we are developing the already developed project. Okay, now it's not happen that every time, it's not necessary that we'll going to develop or introduce a newly project or a very new project. Okay, sometimes it might happen that we'll develop a already developed project, or we can say that we'll enhance the already developed project by using the client's feedback, or by reviewing, by taking the reviews from the marketing team. Okay, so we can decrease the flaws of the product, and then we can overcome them. Okay, now the second comes is the turnkey project execution. Now, as its name implies, what is turnkey project execution? So, turnkey project execution is based on the requirement given by the clients. Now we have seen that in the product development we have redeveloped the project, but in turnkey project execution we are going to develop a new project which is based on the client's requirement. Okay, so this project which we develop under the turnkey project execution is a very new project. Okay, now the next is the problem definition. As I told you earlier, that problem definition is the raw material of every system. Okay, so it plays a vital role in that. Okay, because our problem definition should be so precise, or we can say that it should be so clear, or I can say that it is the shadow of our project. Means what we are going to develop in our project, what are the flaws of our project. It all should be specified in our problem definition. Okay, it also includes what are the highs of our project, what are the lows of our project, which are the technique we are going to use, what are the advantage of using those techniques. All this requirement should be specified in our problem definition, but in a very precise way. Okay, now we have created the problem definition. Okay, but now we are going to convert the problem definition into a detailed requirement document. Okay, so the journey of converting problem definition into validated SRS is divided into three parts. Okay, the first is the requirement analysis, second is the requirement specification, and the third is the requirement validation. Okay, so the first phase is requirement analysis. Ma'am, next slide, please. So, what comes under requirement analysis? So, what are the inputs of the system? What are the desired outputs of the system? What the process to be done by the system along with the time restrictions? What is the supply voltage? What are the communication interface to be provided? What is the size of the embedded system? Which operating environment is to use? And what are the standards to be followed? Okay, now we have to gather all this requirement, or we have to analyze all this requirement on the problem definition. Okay, now the second phase. Ma'am, next slide, please. Now, once these requirements are obtained, they need to be documented, and a document called requirement specification, which is to be prepared. Okay, now it is divided into another two parts, that is functional requirements and non-functional requirements. Now, what are the functional requirements? Functional requirements means what are the functionalities which are provided by our project, and what is non-functional requirements? As you can see on your screen, these are the non-functional requirements. Means what? Reliability, delivery time, implementation requirements, standards, safety requirements, and security. Now once all this requirement specification is done, then we move towards the requirement validation phase. It is the third phase, and the requirement validation phase is to ensure that the the requirement specifications document captures all the requirements of the user, and also to ensure that the required embedded system can be designed and developed. Now, what does it mean? So, the requirement validation phase is gives us the surety that we are going to develop or design a project as per the requirements. Okay, ma'am, next slide, please. Now, the second phase is the designing phase. Now, The design goals are to meet all the functional and performance requirements, to reduce the size and cost of the system to the extent possible, to reduce the power consumption of the system, to reduce the development time and effort, to reduce the maintenance effort and time, and to increase the reliability. Now, when we are designing our system, we have to design our system such that we have to keep all these goals in our mind when we are designing our system. Okay, so the design process, as we know, is divided into these many parts, like hardware, software, which is called as co-design, or the hardware design part and the software design part. Ma'am, next slide. Now, the hardware design part. So, the hardware design involves selection of the processor, calculation of memory requirements and types of memory, identification of input device, identification of output device, identification of test points, that is a JTAG debugging or design board, keeping in view of debug pins, identification of supply voltage and current requirement for designing the power supply unit. Start with the block diagram and then convert it into the circuit with necessary interconnections. And hardware design is not done in isolation, it requires interacting with software engineer also. Now, what is the selection of the process? So it means that which processor we are going to use out of microprocessor, microcontroller, or digital signal processor. So according to the need, the processor is selected. Now the next is calculation of memory requirements and types of memory. Now, as we are having various types of memory, that RAM, ROM, hybrid memory. So according to the need, the memory has been chosen. Okay, and according to the memory requirement. And according to the memory requirement, the memory is also calculated, because if our system is small, so there is no need of the larger space. Okay, and uh, if our system is small, so we can't means there is no use of using there is no need of using the largest memory. Now the next is identification of input device. Now input device plays an important role, because we need an interface, and interface is nothing but the input device. The same thing is applied on the output device. Then when we are identifying the output device, uh, so the same rule is apply as the which is applied in the input device. Okay, so according to the need of the system, the devices are identified. Now, identification of test points. Now, what happens in identification of test points? The design board is having the debug pins, right? And by using these pins, we can debug or test our system. Okay. Now, the next point is identification of supply voltages and current requirement for designing the power supply unit. Okay, now to according the size and usage of our system, voltage is identified as per the need. Okay, and according to need, the current requirement is also specified according to the power supply. Okay, now the next is start with block diagram and then convert it into circuit with necessary condition. Okay, now we all know, if we want to finalize product, or if we want to suppose take example of your drawing. If you want to draw something, you then what you do is, you will in starting you will draw the basics of it, or we can say that we can draw the block diagram. The same rule is applied here. What happen is, every time we starts with the basic block diagram, and after finalizing it, after completing the block diagram, we start to convert the block diagram into a complete circuit, and with the necessary interconnections. Okay, now, the next come is, hardware design is not done in isolation. It requires interacting with software engineer. Now, what does it mean? As the hardware design team is having many engineers, okay, who are working separately on separate sections. Okay, so The hardware design is not done in isolation. There should be a good synergy between the hardware and software team, or I can say that there is a good interaction between the hardware and software team. Ma'am, next slide, please. Now, software design. So, software design involves working out the details of processing to be done in embedded system, decomposition of processing into different tasks, calculation of the processing time and resources required for each task, deciding on the use of embedded operating system, studying the need for support for communication protocol stack, study the need for embedding the HTTP server software, and study the need for field upgrading of the software. Now, working out the details of processing to be done in ES. Now we have to do the detailing of the processes which are going to work in the or which are going to done in embedded system. Second is decomposition of processing into different tasks. Now, what is decomposition? So, decomposition is simply the division. Okay, so we have to divide the process into smaller task or different task, and according to that, the processing time is calculated and the resource requiring for each task is also calculated. Now, which operating system is to be applied, it is decided over there. Again, what is the need for support for communication protocol stack. Study the need for embedding the HTTP server software, and study the need for field upgradation of the software. These all many requirements, or these all many design, these all many goals are specified in the software design. Ma'am, next slide, please. So now implementation phase. So implementation phase involves hardware implementation. What it does, developing the schematics, obtaining the PCBs, procuring the components, assembling the components, and testing the individual modules on the populated PCB, testing the complete hardware. Now, developing the circuit schematics. Now, what does it mean? As we know that we have drawn the block diagram, and then we have converted the block diagram into circuit, and then it is implemented. Okay, now obtaining the PCB. Now, what is PCB? So, PCB is printed circuit board, and is the vital part of any embedded system. Now, now we have to procuring the components. Means what we have to do, we have to obtain all the components which are necessary in the hardware side. Okay, now assembling the components and testing the individual modules on the populated PCB. Now we have to assemble all the components which are necessary in the which are necessary in the hardware implementation, and we have to test the individuals. Okay, now testing the complete hardware. Now in the previous stage we have tested the components individually. Now we have to test the complete hardware. Okay, next, that is the software implementation, and it involves converting the design into code. Implementation of the software is generally done on the host system, and then executable code is transferred to the target hardware. Now, converting the design into code means that at software side, the algorithm is prepared, and then the algorithm is converted into the code. Okay, and the implementation of software is generally it's done on the host system, and the result, or we can say that the executable code is transferred to the target system. Okay, ma'am, next slide, please. Now, integration and testing. So up till now we have seen all the stages till implementation. Now we will learn the integration. Now, as I told you earlier, what is integration? So integration is we have integration is done. So in the second stage we have partitioned the designs. Okay. So in integration we will combine those units into a singular system, and after integrating those, we will perform test on it. Okay, now what is testing and why it is done? So testing is done to prove that the system is working correctly or not. or the testing is the process to reduce the risk associated with the residual defects. Now, as I told you, that testing is done to verify that our system is working properly or not, that the flaws which are inside our system is are removed or not. There's all many goals are satisfied in the testing phase. Now there are types of testing: black box testing, white box testing, performance testing, gorilla testing, field trial testing, acceptance testing, and regression testing. So according to the need of the system, the testing is performed on the system. Ma'am, next slide, please. Now, testing the embedded system, it involves two steps: testing on the host system and testing on the target system. Now, testing on the host system involves to validate the software. Tools such as ROM emulator, code simulator, in-circuit emulator, etc. Testing the hardware functionality partially, and performance characteristic cannot be tested on the host system. Means we have to validate the software. We have to use a tool such as ROM emulator, code simulator, in-circuit emulator, and we have to test the hardware functionality partially at the host system. Okay, and the performance characteristics is not tested on the host side; it should be tested on the target side. Now, testing on the target system involves functional requirements. All the functional requirements are tested on the target system. Performance requirements, all the performance requirements are tested on the target system, and all the environment requirements are also satisfied on the target system. Ma'am, next slide, please. Now, packaging. So it's the last stage. Okay, and it is done after testing. And the attractive packaging is must. Now, it's the human tendency that attraction is the, we can say that the attraction is the primary need. Okay, so when the system is very attractive, it can attract the attention of the client. Okay, so the packaging must be attractive, should be packaged in the desired cabinet, that the system should be packaged in the desired cabinet. Okay, and the last is the packaging issues need to be considered from the requirement engineering stage. Means what are the packaging issues is to be taken in the consideration from the very first stage, that is requirement engineering. Thank you. Over to you, ma'am.
Uh, Very nice, Samiksha.
Thank you, ma'am.
And you have explained in a very nice way. I hope all students understood in a very right path. Right, dear students? Have you understood the concept?
Yes,
Yes,
madam.
you. Yes, yes. Thank you, Prasad, for the response.
Yes.
So, thank you so much. Thank
Yes,
you.
ma'am.
Thanks a lot, everyone. She has explained it in very nice way. She was preparing it, and all the things, in fact, including all the phases, Samiksha explained in very nice way. So please fill the feedback form which I have provided in the chat box. That is the peer teaching feedback form, and I am very happy that Samiksha has taken this initiative and done her peer teaching for this embedded subject, and it was done in very nice way. So I would request everyone to please fill the feedback form. After filling, acknowledge in the chat box so that I will know, and then later I will take the attendance. Thank you so much, Samiksha. Thanks a
Thank
lot
you, ma'am.
for sparing your time and for guiding everyone. I also personally liked your session a lot. That's a feedback from my side. Being
Thank you, ma'am.
student
Thanks a
means
lot.
if I went to the student phase and I have studied from that point of view, so definitely you are having the quality of being a good teacher, and because of that you have done the peer teaching in a very nice way. Thank you so
Thank
much for the superb session.
Thank you, ma'am. It's my pleasure.
Thank you,
Thank you.
Sameeksha.
So please fill the feedback form, and after that we will take the attendance.